Hello friends, welcome back. So what we are doing class 9 chapter 1 number system, and already we have done till exercise 1.3 and 1.4 we are not doing, it's not required, so we'll do today 1.5. Okay, in 1.5 we have 5 questions, and before we proceed further, let's understand some basic points. Okay, because before you understand any concept, if you directly jump to exercise, it become very difficult. So let me explain in brief the important points of this exercise. Okay, so let's start. See here, rational number, as we know, rational number p by q. Okay, or any terminating decimal expansion repeating. All right, an irrational number, a number which cannot be read in the p by q form, and non-terminating, non-recurring. And if I add rational and irrational number, we'll get irrational number. The best example, root 2. Let's take irrational number. Let's take rational number. 2 is a rational number plus root 3 is a irrational number. So we'll get 2 plus root 3 only. So this is irrational number. This is my rational number. This is irrational number. Together if I add, I'll get irrational number. Similarly here, rational number minus irrational number, same irrational number. Same example I can take. 2 minus root 5. This is my rational number, this is irrational number. If I subtract, I'll get again 2 minus root 5, because I cannot subtract these two. I cannot subtract a rational number and then irrational number. It remains as it is. Number 2, finish. Number 3, rational number. See this number 3. Rational number multiply by irrational number, you'll get irrational number. The best example of this is rational number is 2 into irrational number, you can take root 3. If I multiply, I'll get 2 root 3. So this is my rational number. Okay, let me write here. Point number 3. Okay, point number 3 is 2 into root 3. 2 is my rational and root 3 is irrational. If I multiply, I'll get 2 root 3, which is my irrational number. That means rational multiplied by irrational is irrational number. Okay, similarly, the question number 4. Concept number 4, rational number, if I divide by irrational number, I'll get irrational number. Example, so example 4, okay, example 4, point number 4. 3 is my rational number. If I divide by irrational number, okay, I'll get irrational number. Alright, this can be done like this. I'll show you this also in this exercise, root 5 and multiply by root 5. Okay, so 3 into root 5, this 3 into root 5, 3 root 5 by root 5 into 5 is 5. So I'm getting 3 by 5 root 5. This is my irrational number. This is 4. Rational number, alright, multiply by irrational number, same. Rational number, if I divide irrational number, I'll get irrational number again. Okay, this example will be 2 by root 3. See this one, divisions. Okay, if I divide rational and irrational, I'll get again irrational number. Alright, 5. What about 5? Sum, difference, product or quotient of two irrational number may be a rational or irrational number. Okay, let's take irrational number and one more irrational number. Let's multiply irrational number, I'll get root 6. So it is an irrational number. Sometime, see, sometime if I take root 3 irrational number, again root 3 irrational number, if I multiply, I'll get 3 is a rational number. So sometime irrational, sometime rational. So same with the case of sum, difference or divisions. If you have two irrational number, and if you multiply or divide or take sum or do difference minus, they sometime you may get irrational number and sometime you may get rational number. Is it okay? Alright, so let me rub all this. I hope you understood all this concept. Rational number 1, number 2, number 3, number 4, number 5. Let's do number 6. See, if you have, see, if a, b, n are real numbers, okay, you take to be any real numbers, and if you have b to the power n equals to a, then what you can write, see, this n will come in the this square root sign, okay, not square root, this is called radical sign, this is called radical sign. This power b to the power n will come here, this a will come here and equals to b, means b will be equals to this, n will come this side and it will become radical sign, and this symbol is called your radical sign. Okay, let me make this more clear. Okay, some more example. Suppose you have, let's take some number, 2 to the power 3 equals to 5. Okay, then you can take 2, this 2 equals to this 3 will come under this radical sign, and then 5. Okay, this 3 will come here and this 5 will remain same as it is. Okay, and this 2 will be this. So this sign is called radical sign. Is it clear? You want to see some more example? Let's take this x to the power 2. If we have 5, then this x will be equals to this 2 will come here and then 5 will be here, and this symbol is called radical sign. Okay, so if you understand, let's do 7, example 7. Okay, this 7 rationalizations. Okay, rationalizing the denominator. That means if I have 1 by root a plus b, and if I am asked to find the or do the rationalization of the denominator, okay, this type of question most need the asked to find the rationalizing or do the rationalization of the denominator. How you do this type of sums? Okay, let me write like this. See, 1 root over a plus b, what did you multiply? Take the same thing, only sign changes, minus. The same one will go in the numerator also. So this is the method of rationalizing the denominator. Rationalizing the denominator means what? If you check nicely, this root a, this is an irrational number. This is my irrational number. Root is irrational number. So I have to rationalize it. Or if you ask to rationalize it, then what I'll do, I'll multiply the same number, only sign will change in the denominator as well as the numerator. Okay, you want to see some more examples? 1 by root 2 minus 3, suppose. So this I'll do what? I'll multiply by root 2 plus 3, and in the numerator also root 2 plus 3, and we'll do the sum. Is that clear? So this is the basic concept of rational and irrational numbers. Means real number. These are all real numbers, isn't it? You remember real number? Real number comprises of both rational and irrational number. So here we have seen the examples of rational number and irrational number, which are actually real number. Okay, real number is rational plus irrational number. Is it clear? So if you understand, let's go to exercise 1.5 and let's dive into it. What is the questions? Example 1. Classify the following numbers as rational or irrational. Okay, so I have to check whether this 1, 2, 3, 4 and 5. There are 5 questions on this example 1. We have to see which is rational and irrational. So this is simply, this is irrational, this is irrational. Why? Because see, this is the difference of rational, this is my rational, and irrational, this is irrational. Difference of rational and irrational number gives me irrational, isn't it? So difference, so this one, so rational number minus irrational number gives me irrational number. So this is the reason. difference of rational number and irrational number is always irrational number. So I'll write here number 1. Let's do number 1. 2 minus root 5. Okay, so let's take number 1. 2 minus root 5. So my answer will be, since 2 is a rational number and root 5 is an irrational number, therefore 2 minus root 5 is an irrational number. Is it clear? Let's do number 2. What is number 2? 3 plus root 23 minus root 3. Okay. Number 2 is 3 plus root 23 within bracket minus root 23. If you remove the bracket, what you will get? 3 plus root 23 minus root 23 equals to 3. Hello guys, are you enjoying? Please let me know. Don't get bored. Okay. These are very simple sums. Just you need to concentrate. That's it. So now I'm having 3. So 3 is a what? 3 is a rational number. Okay, 3 is a rational number. Therefore, it is a rational number. Okay, let's do number 3. What was 3? 3 was 2 by root 7 by 7 by root 7. So this, what I can do, I can cancel this root 7 and root 7. So it will be left with 2 by 7, which is a rational number, which is a rational number. Number 4. Number 4. What is number 4? Number 4 is 1 by root 2. 1 by root 2. See the concept, basic concept. That means first one is, this is my rational number and this is my irrational number. Rational number divided by irrational number. Let's go back to the important points. Rational number, see this number 4 point. Rational number divided by irrational number gives me irrational number. Okay. Since 1 is a rational number and root 2 is an irrational number, therefore what is 1 by root 2? 1 by root 2 is an irrational number. Okay. Number 5. Let's do number 5. Any questions? Let's do number 5. Let's rub it. Number 4. Let's do number 5. 5 is what? We had 5 to pi. I have to tell what is this 2 pi. I have to classify this 2 pi. What is this? Is it a rational number or irrational number? Before doing this, you tell me what is pi. Pi is 22 by 7. Okay. What is pi? Pi value is 22 by 7, which is 3.142 dot dot dot. So this is my irrational number. Pi is irrational number. So pi is irrational and 2 is rational. All right. Rational multiplied and the middle sign is multiplied. Nothing is multiplied. Rational number multiplied by irrational number. Let's go back to this point. Rational number multiplied by irrational number. Point number 3. Rational number multiplied by irrational number gives me irrational number. Isn't it? Here 2 pi is an irrational. irrational number because 2 is a multiplication of that point. Okay, multiplication of rational and irrational number because multiplication of rational and irrational number is always irrational. Okay, so this is question number point number 5 or question example 1. So after this we'll do example 2. Let's do this one. Example is simplify each of the following. You have to simplify. Question number 1 is given within bracket 3 plus root 3, again bracket 2 plus root 2. So 4 questions as given. So let's do one by one. So first one is 3 plus root 3 multiply by 2 plus root 2. I'll write the question again. So the first one 3 plus root 3, 3 plus root 3, and here 2 plus root 2. So how you do? So this one multiply by this one. So what you do? You take this 3. See this step. Take this 3, and with this 3 you multiply the rest of the bracket 2 plus root 2. With this 3 you multiply this bracket, whole bracket. Again what is left? Plus root 3. You have to write the sign also. Plus root 3 is left here. So with this plus root 3 you multiply again the same bracket 2 plus root 2. Okay, this is called what you know, distribution law of multiplication of over addition. This is called distributive law. Distributive law, okay, of multiplication over addition. All right, so now I'll multiply 3 and this 2. 3 into 2 6, 3 into root 2. See, I'm having plus here also plus, so plus here plus 3 into root 2, 3 root 2. So this part finish, come back to this part. Okay, let me rub this. This I can write 2 root 3. Okay, this root 3 and this 2 multiply 2 root 3 plus root 3 into root 2. I'll get root 6. So multiplication rule says number below the under the square root and number under the square root can be multiplied together. Okay, 3 into 2 6. But this rational number 2, and then it will be multiplied by this number. Here it is 1, nothing means 1. So 1 into 2 2. Here again see 1 into 1 1, nothing means 1. Root 3 into root 2 root 6 means under number whatever you have inside the root or under the root, that can be multiplied together. All right, is it clear? So this is my answer because I cannot do further. See here, this is my irrational number, this is my irrational number, here the root 1 root 2, here root 3. So I cannot do anything. Here root 6 different irrational number, different irrational number, different irrational number, so I cannot do further. So this will be my final answer. Okay, so let's do question number 2. Question number 2 was 3 plus root 3, 3 minus root 3. So same here. Okay, same 3 you multiplied both this, and plus root 3 you multiply both. This is the procedure of doing. But here one thing you can see, you can take formula a plus b. This is like this formula, a minus b. See, a b same numbers, so I can use directly formula. So a plus b, a minus b formula is a square minus b square. So here also same thing. This is my a, so a square means 3 square. This is a square minus this is b, root 3 and root 3, minus b square is root 3 square, equal. So 3 square is 9, 3 square is 9, minus this one and this one get cancelled. Okay, so 3 equals to 9 minus 3 is 6. So this is my answer. Okay, let's do question number 3. Example, same example but question number 3, and 3 question is this one. Let's do it first. Root 5 plus root 2, root 5 plus root 2 whole thing square. So this is same formula, a plus b whole thing square equals to a square plus 2ab plus b square, as we know this formula. So a plus b whole thing square equals to a square plus 2ab plus b square. This is my a, root 5 is my a, this is my b, this is a, this is b. So according to the formula a square, so I'll write a square. Okay, so root 5 is my a, so a square plus, see, 2ab, 2 into multiply sign here, a is root 5 multiply here, b is my root 2, so root 2 plus b, what is b again, b is again root 2, so root 2 I'll take square. Okay, so this is again 5 because root 5 is square is 5. Okay, this cancel, or root 5 into root 5 is 5 plus 2. Say I told you in the previous question that root under root 5 under root 2 multiply you can have, but plus or minus you cannot do, you have to keep it as it is. But multiply you can write. So I will write 5 into 2, 10 plus again root 2 square is 2, na? This 2, this square get cancelled, so 2 equals to, see, this rational number, this rational number I can add together, 5 plus 2 is 7, and this is my irrational number 2 root 10. So rational and irrational I cannot add together, I have to keep as it is the answer. So this is my answer. Okay, so let's do the question number 4 of the same example. Okay, let me rub it. Question number 4. Here root 5 minus root 2 root 5 plus root 2. So what I'll do here, same method. See, this with this root 5 I can multiply both, again minus root 2 I can multiply both. This is one method, but here again the same formula. See, whenever you get the chance to use formula, please use formula. A minus b, a plus b equals to a square minus b square. My a is this one and this is my b. Okay, okay, so formula a minus b, a plus b, the formula is a square minus b square. So this is 5, no? Root 5 square is root 5 into root 5, that gives me 5, or you can cancel directly, minus same here 2, this 2, this will get cancelled. So my answer is 5 minus 2 is 3. So this is my answer. So I have finished example 2, all the questions. We had 4 questions, we have finished 4 questions of example 2. Let's do example 3. Okay, let's do example 3. So this is my question. Recall pi is defined as the ratio of the circumference C of a circle to its diameter D. That is pi equals to C by D. See, in geometry, okay, in geometry actually we can write in geometry, okay, if I have a circle, this is my circumference, huh? This is C is my circumference. From here, this is radius, huh? And the whole thing is my, from here to here, it is my diameter D. So in circle, we can write circumference as C equals to 2 pi r. You learn in circle. Okay, this is the formula of finding circumference. If I know the radius, then I can find this circumference, okay, using this formula. Or I can write C is equals to 2r 2r pi. Okay, so that gives me 2r is D, and then pi. C equals to D by, or C by D. Okay, that is C by D will be my pi. So pi is C by D. C is circumference, D is diameter. So this one they're talking about here, okay, from geometry. Recall that pi is defined as the ratio of circumference of a circle to its diameter. So pi is the ratio C by D. Okay, this seems to contradict the fact that pi is irrational. Okay, now see, we know this pi is irrational. In this chapter, we know this pi is irrational because pi is 22 by 7, which is 3.142. Okay, this is irrational. But here it seems that circumference have some number, okay, some positive number, and D also some positive number. So it seems like they're contradicting. Here it is irrational number, but here according to this is not an irrational number, isn't it? But actually, let me tell you, see, we do not know this. We do not know this C circumference. We do not know this diameter. We can think that they may be rational number, some number 5, 6, 8, okay, but we are not sure of it. So there is no contradiction, because as either C or D, since this is my irrational number, since so either C or D, any one of them is irrational, because we know division of rational number and irrational number is irrational number. Division of rational number or irrational number is irrational number. That means according to this point, see, point number 4, rational number divides irrational number gives me irrational number. So here the same thing, pi is irrational, so this is my irrational number. So C may be rational number and D may be irrational number. So rational number by irrational gives me irrational number. Is it clear? Since pi is irrational number, we do not know exactly, so either of C or D will be an irrational number. Any one of this will be an irrational number. Okay, so there is no contradictions. So what I'll write here, let me rub it. Let me rub it and write solution. There is no contradiction. There is no there is no contradiction, as either C or D, circumference or diameter, is irrational, and hence pi is irrational. Okay, So this is question number, example number 3. So in example 4, this one, represent root over 9.3 on the number line. This I'll do later. Okay, we are left with some root 2, root 3, those type of numbers on the how to represent all irrational number on the number line. Along with that, I'll do. Okay, I'll bring very soon this type of videos on this type of questions. Okay, so I'll do later. So let's finish number 5. Number 5 is rationalize the denominator. See this one, this point. I told you that time. See this point number 5, rationalization. How you do rationalizations? Whatever you have, you multiply the same number, just the sign will be changed. Okay, so number 5. Question number 5. Let's do question number 5. So here rationalize the denominator of the following. Number 1, 1 by root 7. So what you'll do? Simply I'll multiply here by, see root 7 I do not have any sign, so I'll simply multiply here root 7 here, so root 7. Okay, see here I'll multiply what? I'll multiply here root 7 plus root 6, the same number I'll take in the numerator. No, I told you no. Here I'll multiply what? Root 7 minus here I'll take minus plus 2. Same root 7 plus 12 multiply here. Here I'll multiply root 5 minus sign will change. Number will remain same, sign will change, and the same number whatever I have taken here I'll go in the numerator. Finish. And you multiply. Okay, so let's do 1 by 1. So 1 by root 7. I'll take number 1. Solution 1, 1 by root 7. So what I'll do? I'll multiply this one. Okay, equals to 1 by root 7. I'll multiply the numerator and the denominator by root 7. Here is no sign, plus minus. So I'll take whatever number I have here, this side also, and the same number in the numerator. Okay, so equals to give me what? Root 7. See, 1 into root 7 is root 7. Okay, and here root 7 into root 7 is root 7 into root 7 gives me 7. And what I have done here, multiply and divide, multiplying and dividing by root 7. Okay, here this part, and here root 7 into root 7 is 7. As we know, root 7 into root 7 will be root 7 square. So this gives me root 7 is cancelled, so 7. Okay, so this is my answer. Question number 1. Let's do question number 2. What was question number 2? 1 by root 7 minus root 6. See this one, 1 by root 7 minus root 6. So I'll multiply the same one. 1 by, okay, number 2, 1 by root 7 minus root 6 equals to 1 by root 7 minus root 6. I'll multiply this one, root 7 plus root 6, root 7 plus root 6 equals to, I'll multiply here root 7 plus root 6. Now with 1 it remains same, but the denominator, see, root 7 minus root 6, root 7 plus root 6. We know the rules. With root 7 I have to multiply both, and again minus root 6 I have to multiply both. This is one of the rules. Second rule says if you can use a formula, you can use a formula. Here, see, a minus b, a plus b formula I can use. So I'll use directly. So root 7 whole thing square, a square minus root 6 whole thing square. Since a minus b, a plus b gives me a square minus b square. Okay, a square minus b square. So this is the formula I have used here. Okay, so in the numerator root 7 plus root 6, and in the denominator this root 7 square is 7, root 6 square is 6. This gives me root 7 plus root 6 by 1 okay, which gives me root 7 plus root 6 equals to root 7 plus root 6. So this is my answer. This is rational number, irrational number, this also irrational number. Okay, so addition of irrational number itself is an irrational number. Let's do question number 3. Root 5 plus root 2. Okay, this one, 1 by root 5 plus root 2. Number 3, 1 by root 5 plus root 2. Same method, 1 by root 5 plus root 2. What I'll write here? Shall I write here root 5 plus root 2? Is it okay? This is correct or incorrect? This is incorrect. I had written this intentionally because here plus I'll have to write here minus. Minus, okay? Sign changes. Sign changes. In the numerator with 1, if I multiply it will remain same. So root 5 minus root 2. Okay? Here you write the reason, okay? Multiplying and divide by root 5 minus root 2. Okay? This numerator and in the denominator root 5 plus root 2, root 5 minus root 2 means a plus b, a minus b formula. So this I'll get here a square minus b square. Okay? Equals to root 5 minus root 2 and the denominator this 5 minus this one is 2. So it gives me root 5 minus root 2 by 5 minus 2 is 3. So this is my answer. Let's do the last one, 4, and 4 was your 1 by root 7 minus 2. Okay, equals to what I'll do, 1 by root 7 minus 2, I'll multiply the same number but the sign will change, minus will become plus. Okay, this is root 7 plus 2 and see here a minus b plus b formula again. So root 7 whole thing is square minus 2 whole thing is square. This I'm using formula since you write the reason also. A minus b, a plus b is equals to a square minus b square. Okay, so this gives me root 7 plus root 2, 7 minus 2 equals to root 7 plus 2, 7 minus 2 is 5. So this is my answer. So I hope you understood. So this is the end of exercise 1.5 also. So I am left with one more exercise, that is 1.6. okay, 1.6, okay, that I'll do in the next class. Okay, thank you for watching. Bye bye and take care.